Welcome to Math-o-tropism. Today we are going to see the sum from NCERT class 9th book, chapter 2, exercise 2.4, sum 5, which is regarding factorizing a cubic polynomial, where we are going to use factor theorem for the factorizing. So first let us know about the factor theorem. Let p of x be the given polynomial. If p of a is equal to 0, then x minus a is a factor of p of x. So what do you mean by that is, if we are given any polynomial, we are going to assume that it is equal to p of x, where p of x means it is a polynomial having the terms in variable x. Now, p of a means instead of x we are going to use some value, and that value can be anything. That is why I am using the variable a. So when I substitute the value of a in the given polynomial, it should come to 0. If it is coming to 0, then x, see here, if we are taking a, you should write minus a. So x minus a is a factor of p of x. So we will be generally assuming values for a starting from 1, then minus 1, then 2, minus 2, etc. till we find a value for which the p of a is going to become a 0. So when the remainder, this means that if the remainder is coming to 0, then the divisor is a factor of the dividend, just like how we do in the normal division. For example, 4 divided by 2 if we do, we get the remainder as 0. So it means that 2 is a factor of 4. Similarly, p of a is nothing but the remainder. So when I am taking x minus a as my divisor, then my remainder will come to 0. So to easily find whether the remainder is 0 or not, we are substituting the value in the given polynomial, and then we will be getting it as 0. So let us take an example. P of x is x cube minus 2x square minus x plus 2. Now, since we are starting with 1, so when I substitute instead of x1, p of 1 will now be 1 cube minus 2 into 1 square minus 1 plus 2, which is equal to 1 minus 2 minus 1 plus 2, which gives 0. So our condition is satisfied that p of a, that is p of 1, is 0. So it means what? My x minus 1 will be a factor of the given polynomial. Now, another simple method is, for finding if p of 1 is equal to 0, just add all the coefficients of the given polynomial. So here we have x cube's coefficient as 1, x square terms is minus 2, x is minus 1, and the constant term is 2. So sum of all the coefficients is coming to 0. So instead of substituting and finding 1 in the polynomial, we can just take all the coefficients, check it. If addition of all the coefficients is 0, then we can directly write that x minus 1 will be a factor of the given polynomial. Now let us take another example. P of x is equal to x cube minus 3x square minus 9x minus 5. Now, we must first substitute 1 and see whether it is a factor. So I have already told you, we just need to add the coefficients. So if I add 1 minus 3 minus 9 and minus 5, we can see that it will not come to 0 as the negative terms are greater than the positive terms. So it means I go to the next a value, which is minus 1. So when I substitute minus 1, what happens? Minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 plus 5. So this comes to minus 1 minus 3 plus 9 minus 5, which is equal to 0. So for this polynomial, my p of 1 minus 1 is becoming 0, which means x plus 1 will be a factor. Remember, whatever a we are taking, x minus a we need to put. So since here it is minus 1, so factor will be x plus 1. Just like how we had a simple calculation for finding if p of 1 is the factor, minus 1 is a factor. Similarly, if we want to check if p of minus 1 is going to be 0, then you need to add all the odd degree terms of x together and the even degree terms together. So what are all the odd degree terms here in this p of x? The x cube term and the x term, and the even degree terms are the x squared term and the constant term. So when I take odd degree terms, it is 1 minus 9 is equal to minus 8, and if I take the even degree terms, it is minus 3 minus 5 which is equal to minus 8. So when we see odd and even degree terms, values if on adding is the same, then p of minus 1 will be 0, or otherwise x plus 1 will be a factor. So by factor theorem, first we need to find a value for which p of a or the remainder is 0, and if it is 1, we can just add all the coefficients and see whether the value is 0. If it is yes, then x minus 1 will be a factor. If even terms coefficient addition and odd terms coefficient addition is equal, are the same, both are the same, then x plus 1 or p of minus 1 is equal to 0, and x plus 1 will be a factor. So we will be using these 3 steps in the coming sums in the exercise. So first sum is x cube minus 2x square minus x plus 2. I will write this as p of x. So first I need to find a value of a such that the remainder p of a is equal to 0. So let me first take 1. So if I do the sum of all the coefficients, it is 1 minus 2 minus 1 plus 2 which is equal to 0. So we can write directly x minus 1 is a factor. So when x minus 1 is a factor, next we need to now write the given p of x as a product of two factors where one factor is x minus 1. We get x minus 1 as a common factor. So how do we do that? The given polynomial is x cube minus 2x square minus x plus 2. We'll go one term at a time. So first if we see the first term is x cube, it is going to remain the same. So I write that x cube normally. Next, I need to find what term I should put so that I can get x minus 1 as a common factor along with x cube. So we can see that if I put a minus x square term, then x cube minus x square will have a x square term common which I can take outside, and the balance remaining term will be x minus 1, which is the common factor I need. So I write a minus x square after the x cube term. But in my given polynomial, I have a minus 2x square term. So if one x square has already gone, I need to find out what balance term of x square I need to write. So for that, you first write the term in the given polynomial. So that is minus 2x square, and I have already written one minus x square, so I am going to subtract that from this number. So I will be writing minus 2x square minus of minus x square. So the balance now comes to minus 2x square plus x square, which is minus x square. So I put that minus x square now next to the previous term. Now I have three terms. The first two terms will come as x square into x minus 1, and now I have a minus x square term. So I need to see what term I need to add to this minus x square so that I can get an x minus 1 as a common factor. So if I add a plus x, So minus x square plus x. If I take a minus x outside common, I get minus x into x minus 1. So it means I need to add a plus x term. So next I am writing a plus x. Again I need to check the balance. So what is the x term in the given polynomial? Minus x. Again minus of whatever we have added now. So minus of x. So that gives me minus 2x. So write that balance again. Now for this balance I need to find what term to add to get a minus x minus 1 as a common factor. So minus 2x plus 2 if I write, I can take a minus 2 outside and get a term of x minus 1 common. So it means the last term which I am introducing, I don't need to introduce because that is what is given in the given polynomial. So I just need to write a plus 2. So this is how we are going to do. I will explain it. Now I take two terms at a time. First two terms x square is common and x minus 1. Minus of next two terms x is common, again x minus 1. Last two terms minus 2 is common, again x minus 1. So this comes to x minus 1 whole common taken outside. Balance remaining terms are x square minus x minus 2. So we can see that the cubic polynomial has now been factorized into two polynomials of degree 1 and 2. One is what we had found using the factor theorem, and now the balance remaining quadratic polynomial I need to factorize. We can factorize by using splitting the middle terms. If you want to know more on how to factorize a quadratic equation, you can see the video Factorize by Splitting the Middle Terms part 1 and part 2 in my how to do playlist on this channel. Coming again to factorizing, I need to factorize x square minus x minus 2. For that, let me take a is equal to 1, b is equal to minus 1, c is equal to minus 2. So ac is minus 2. Since ac is negative, it means I need to find two factors such that minus is there, so both should be subtracted to get the b term, and both will be of the opposite sign. So 2 can be factorized into 1 and into 2, so that minus 2 plus 1 is giving me the b term minus 1. So x square minus x minus 2 can be rewritten as x square minus 2x plus x minus 2. So now I again take first two terms together and the next two terms together, find the common in them. We can find that x is common, and then balance remaining terms is x minus 2. In the last two terms plus 1 is common, x minus 2 is again a balance remaining term. So this comes to x minus 2 into x plus 1. Another way is we find the HCF of the two terms separately and write it over here, where HCF is written outside and the last remaining terms in the factorization after prime factorization is what is written inside. Another thing which we can notice is, since this is same for all the sums with x square coefficient being 1, we see that whatever we had split the AC into, we had split minus 2 and plus 1. The same thing will only come in the answer. So we could have directly written x minus 2 into x plus 1. So x cube minus 2x square minus x plus 2 is equal to x minus 1 into x minus 2 into x plus 1. The next sum is x cube minus 3x square minus 9x minus 5, which we will consider as p of x. So I need to find p of a such that it is equal to 0. When I first assume 1, I see that the sum of all coefficients 1 minus 3 minus 9 minus 5 is not equal to 0. So it means my x minus 1 is not a factor. So I need to now consider a is equal to minus 1. So for minus 1, as we saw, we need to take the odd degree terms. So 1 minus 9, which is minus 8, and even degree terms, which is minus 3 minus 5, which is minus 8. So both are coming to minus 8, which means that p of minus 1 will be equal to 0, or x plus 1 is a factor. So what is the next step? I need to introduce terms such that I get x plus 1 as a common factor. So I write the polynomial x cube minus 3x square minus 9x minus 5 is equal to x cube alone. The first term alone I should write. I now need to add a term in such a way that I get a common of x plus 1. So what do I need for x cube? I need a x square term, so that x cube plus x square will give me x square into x plus 1. So I write that x square. Now original one has minus 3x square, so I need to find the balance. So minus 3x square minus of the term which we just now found, so x square. So this comes to minus 4x cube. So I need to write next term as minus 4x cube. Now I need to find the term which I should add to minus 4x square. So what is that term? If I add a minus 4x, then I can take a common outside of minus 4x, so that the terms inside will now become x plus 1. So I write that minus 4x as the next term in the given polynomial. After finding the need, I need to know the balance. So what is the already x term in the given polynomial is minus 9x, minus of what have I found? Minus 4x. So that comes to minus 5x. So I write that minus 5x next. Now what do I need for minus 5x? I need a minus 5, so that when I do take common outside of minus 5, balance remaining term is x plus 1. So I can check that the last entry is the same as what is given in the polynomial. So I don't need to write anything extra. I just am adding the minus 5 in as the last term. So remember, if we are doing this properly, the last constant term always is what we will be getting in the last step for the needing of the x term. Okay, so now here again, first two terms x square into x plus 1 is common, minus of 4x into x plus 1, and the last two terms minus 5 into x plus 1. If I take a x plus 1 common outside, balance remaining terms are x square minus 4x minus 5. Now I need to factorize this quadratic polynomial. So AC is 1 into minus 5, so minus 5, b is minus 4. So I can split it into 5 as 1 and 5, with 5 having the negative sign of the b, because both opposite signs only I can get the b value, since AC is negative, and the other term is plus 1. So as I already told you in the previous slide, I can directly write it as x plus 1 into x minus 5. I have just worked it out for you. So from step 2, x cube minus 3x square minus 9x minus 5 can now be written as x plus 1 into x plus 1 into x minus 5. Next is x cube plus 13x square plus 32x plus 20 is equal to p of x. What we'll be now doing is, we are going to take a is equal to 1. So 1 plus 13 plus 32 plus 20 is not equal to 0. So x minus 1 is not a factor. Now again I substitute minus 1. So I need to take the odd degree terms 1 and 32. When I add, it comes to 33. Even degree terms 13 and 20, that is also 33, which means p of minus 1 will be equal to 0. So x plus 1 is a factor. Now I need to introduce terms to get x plus 1 as a common factor. So again x cube plus 13x square plus 32x plus 20. I will be writing it as first x cube alone. What do I need for x cube? I need x square term, so that x square into x plus 1 is a common thing which you can write. What is the balance? In the sum it is 13x square minus of what we have just now found. So 13x square minus of x square gives me 12x square. Now I need to find for this 12x square balance what I need to add. So 12x square plus 12x will give me 12x into x plus 1. So it means next I write a 12x term. After that I need to find the balance. So original has 32x minus of this 12x which we found, that comes to 20x. So I write the 20x. After writing 20x, what should I add so that it comes to x plus 1? As a common factor, it will be 20 into 20x plus 20 will give me 20 into x plus 1. I can see that this is what 20 is already there in the given polynomial. So the way I have split it is correct. So I just add the 20 over there. So first two terms common outside, x square into x plus 1. Next two terms 12x is outside, and then again last two terms 20 is outside. So I take x plus 1 whole common outside. So the balance remaining terms in the quadratic polynomial is x square plus 12x plus 20. Now I need to factorize this x square plus 12x plus 20. I can see AC is positive, so I need to add both the factors to get the B, and also both will have the same sign as B. Here B is positive, so both factors also will be positive and added. So when I see 20 can be split into 10 and 2, so that when they are added it gives a 12. So I will directly write it. So x plus 10 into x plus 2, since my coefficient of x square is 1. So x cube plus 13x square plus 32x plus 20 is equal to x plus 1 into x plus 2 plus into x plus 10. The next one is 2y cube plus y square minus 2y minus 1. Similarly, I need to find a value such that p of a is equal to 0. Let me take first a is equal to 1. So I check all the coefficients. So it comes to 2 plus 1 minus 2 minus 1, which is equal to 0. So p of 1 will be equal to 0. So y minus 1 is a factor. Step 2, I need to introduce the terms to get y minus 1 as my common factor. So I can see that I will first write the polynomial. So that comes to 2y cube plus y square minus 2y minus 1 is equal to 2y cube. What do I need for 2y cube to get y minus 1 as a factor? I need a minus 2y square. So that 2y square into y minus 1 will be my common factors. So I add a minus 2y square. So I need to find what is the balance y square term. So original polynomial has y square minus of what we have just found, minus 2y square. So that comes to 3y square. So I add the term plus 3y square. Now I need to find what I should add with this 3y square to get y minus 1 factor as a common factor. So 3y square minus 3y will give me 3y as a common one outside and y minus 1 factor. So next you write minus 3y. So what is the balance remaining y terms? The original one has minus 2y and minus of minus 3y. So this comes to plus y. So what do I need to add to the plus y to get a y minus 1? We just need to add a minus 1, and we can see that is what is already there in the given polynomial. So our splitting is correct. So again, taking two terms at a time, I can write it as 2y square into y minus 1 plus of 3y into y minus 1 plus of 1 into y minus 1. So this comes to y minus 1 into 2y square plus 3y plus 1. Now I need to factorize the quadratic polynomial 2y square plus 3y plus 1. So a is 2, b is 3, and since AC is positive, both my factors will be added to give the middle term B, and both will be of the positive sign as B is also positive. So 2 can be split into 2 and 1, so that when I add 2 plus 1 it gives me 3. So my 2y square plus 3y plus 1 is equal to 2y square plus 2y plus y plus 1. I cannot directly do because my coefficient of y square term is now 2. So first two terms have a common factor of 2y and the balance remaining term is y plus 1. Similarly, the next two have a plus 1 as a common factor and the balance is y plus 1. So it comes to y plus 1 into 2y plus 1. So 2y cube plus y square minus 2y minus 1 is going to give me y minus 1 into y plus 1 into 2y plus 1. Hope you understand. In all these sums, first we need to find a value such that the P of A or the remainder is 0 by the factor theorem. Then we need to introduce terms to get that factor, and then finally factorize the quadratic polynomial which we get as the other factor. Thank you.